Hey, Sathpal.
Hello.
Hello.
Hi, Sharwani.
Hi.
Hi.
Hello everyone.
Right.
I was thinking just to check if everything's okay.
Sure. Yeah.
Present. Hello.
Yeah.
Okay. We'll wait for a couple of more minutes before we start, and yeah, let's get going. Around 8:05 or something.
Sure.
Also, note for the folks who have joined the call, if your friends have registered via the OCG platform, can you please share the Zoom link with the people around, my friends or colleagues, whoever has registered, if they have not received the mail yet? Yes.
Hey everyone, Atul this side. Good evening.
Hi, Atul. How are you?
Hey Sathpal, I'm good. I'm good. How are you? Thank you so much for joining and doing this.
All well. All well. Yeah. Let's see how it goes.
Yeah, definitely. We'll probably give in a few minutes for folks to join and then Sarvani can drive it.
Sure. Yeah.
Hi everyone. Thank you for joining on a Tuesday evening. I hope all the calls for the day are concluded. Also, thank you so much for registering via the new platform. This is our first time hosting something via OCG, and yeah, welcome to the meetup. Since we have a bit of time, you can drop in your intros. In the chat. We can get to which.
Sorry, you're breaking, Sarvani.
Okay, just give me a minute.
Maybe you can switch off the video for
Yep.
Better network bandwidth. Yeah.
Just a second. Okay. Okay, I'll go offline. I hope it's clear now.
Much better. Go on.
Yep. Yep. Sorry for the interruption. Thank you so much, everyone, for joining in today. I hope the evening calls are all concluded. This is our first time hosting via OCG, and this is our fifth virtual meetup of the year. We started CNCF Hyderabad virtual meetups as a part where we wanted to reach out to a large number of folks compared to what we have in the offline meetups. And via this medium, there are a lot of people who join in from all across the country. And this gives us much better opportunity to get to know each other and, get to have some great talks and all. I'll be starting in shortly. We so before I start, it would be great if everyone can drop their intros in the chat box. Just a short introduction, just getting to know each other. Yep. This is the sort of networking that we do in offline events, I would say. Yeah.
Sarvani, just to check, is this session recorded or it's recording?
Yes.
Yeah.
This
Okay.
is
Being recorded, right? Okay.
yeah.
So probably participant can also switch on their video,
Cameras.
right?
Yeah. It would be great to interact.
Yeah. I see Bhargav. Great.
Let me know if my screen is visible.
Yes, it is.
Okay, so welcome to the May virtual meetup. This is being held on 28th of May. This was supposed to be yesterday, but because of some issues, we had to postpone it to today. Before we start the whole meetup, let me introduce myself. I'm Sarvani. I work as a developer advocate at InfraCloud Technologies, which is an improving company. I code, I test, and then I write about it. We write blog posts, we do POCs, and everything around cloud native. I have also been speaker at CNCF community meetups and Women in Cloud Native meetups. Apart from my apart from my professional life, I love journaling. I write poems and few other stuff. These are my socials to reach out to. Yeah. Before getting into today's topic, I just want a quick show of hands on whoever is joining the first time for any cloud native community call. Yep. I don't know if you guys have hand raised. Great. So I see a lot of folks joining in. A lot of folks have already joined Cloud Native, CNCF meetups and calls. But just to give you an introduction about CNCF, CNCF is a non-profit organization which basically works anything around cloud native computing. Now, cloud native works on a set of principles, and this helps us build better and efficient cloud native cloud applications. Uh, CNCF also hosts. CNCF is also an umbrella for a lot of open source projects. They are also divided into a lot of tag groups and different things. Some of the major projects are Kubernetes, Prometheus, Ebony, Grafana. All these comes under CNCF, and CNCF maintains them. This also provides a vendor-neutral home for open source and cloud-native projects, which helps us in better collaboration and understanding about the system. Coming to Cloud Native Hyderabad chapter, we started in 2019. We have been organizing meetups almost every month, and we started this with only one goal, that is to give free learnings around the Cloud Native ecosystem to anyone in and around Hyderabad. Now, coming to Cloud Native Hyderabad virtual meetups, this is a series which we started this year, and we usually drive it in the second week of each month. This again is a virtual platform for the learnings around Cloud Native. We decided to do this because we had a lot of registrations coming in for offline event, and we decided that it is good to have a parallel running virtual event where people can join in, network, and gain better insights. These are our socials, CNCF Hyderabad. We have LinkedIn, Twitter, YouTube channel. We post all our talk recordings over there, offline and virtual talks as well. So you can check out that. This community.cncf.io is now changed to a new website. We will be sharing the link in the chat soon. And via that page, you can access to the Cloud Native Hyderabad chapter. To keep the chapter up and running, we have few volunteers who contribute us with the content for socials, who contribute us for the amazing posters, designs, and everything. We thank Anand, Anu, Sai, Manoj, Ravanti, Ashwin, Fahad, and Rohit for their contribution towards the chapter. They are the backbone who keeps the chapter running. Now, today's topic for this meetup is Ghost in the Mess, and this is regarding basically Sathpal will walk us through how AI assisted RCA can be done for the distributed systems. Introducing Sathpal Singh, our speaker for today. He is associate director at UBS, and he also organizes local meetups of Grafana and Friends Hyderabad, Global AI Hyderabad, and a lot of different things. If you have attended any meetups in Hyderabad, you'll probably find Sathpal there, or at least you'll find a person who knows Sathpal. So, over to you, Sathpal, for the presentation. Yep.
Thanks, Aruni. That's so kind of you. Right. So let me share my screen first.
Yep.
All right. Okay. So. Right. Hope my screen is visible of my intro. Right?
Yes.
Okay, cool. Now, thanks to CNCF for arranging this virtual meetup. It's great to see people who can't attend in person through these virtual meetups are actually able to attend such sessions. In fact, Grafana has also started last year, so I think that this will benefit a lot of attendees, professionals across the globe, not only in India, right? So my quick introduction, as Sarvani already told, I'm associate director, cloud AI and observability architect as well. I'm a Grafana champion, and I'm a organizer for Grafana and Friends Hyderabad community. I'm also chapter lead for Global AI Hyderabad, which is sponsored by Microsoft. I'm a certified Kubernetes application developer as well. Yeah, so that's my socials, right? LinkedIn, X, and TopMed, not quite active on TopMed, but yeah, you can always connect with me on LinkedIn, right? Let me escape this and quickly jump on to the topic for today. Let me just minimize this. All right, cool. Right. Hope the this is visible, right? Distributed systems by design. Just confirming.
Yes.
Okay. All right. Now it's good. Right. Okay. Cool. So, um, you know, this this session would more cover the demonstration of how we can observe distributed systems. I'll quickly walk you through some slides, and then we'll see a demo. I have a surprise guest with me as well. There's my demo assistant, which will walk you through the demo along with me. That's going to be exciting. Let's see that later on. But yeah, let's start with the topic for today. Distributed systems by design. Uh, you know, if if the people here on the call are young, they might not be familiar with the monolith architecture of how the layers were written, traditionally. A single application with all the services embedded in that, right? Now that was decomposed, and currently we are following microservices architecture, where not only the application services, but also we have our technical products like Kafka, Redis, Kafka for messaging services, Redis for cache mechanisms, and others, based on your application requirements. So this diagram illustrates how we have transformed our architecture for applications from monolithic to microservices. So it becomes more and more complex when you have your microservices running, interacting with each other. That too, now we have our cloud platforms, where we have Kubernetes as our infrastructure management, which tighten the security. And when a microservices when a microservices talk to other microservices, how the requests are handled, right? It becomes quite complex. And this is not only targeted for any application developer, for a platform engineer, for an SRE, or if you're an architect, or if you're a QA, quality assurance person, right, who want to test. You have to, and you must understand the microservices architecture. That's for sure, right? So this just to give you an idea about what's going to come, right? So the problems are like partial failures. There will be multiple dependencies on different services. There will be a flow, no user. If I take an example of e-commerce website, no users add a product, check out the order, do payment, then shipping, then notification, right? So this is a long form of request, transferring from user till you get the notification of your order. Right. So there may be multiple problems in between, network problems, latencies, your Redis not responding, cache uh, uh, your message gets queued up, right? So we'll all see that the chaos, which I'll demonstrate how failures happen, and then what we see in the dashboard. Are we doing the right way of following? Let's see, the dashboard is all green, and then later on we see some surveys is failed, and the dependencies are failed. How to identify that, right? So as I said, the asynchrony, the casual, capacity, and all. So moving on to the next, right? See, the tools which are used in this project is open telemetry with LGTM, which gives us great insights of the system. Open telemetry is the second most popular project on GitHub. Go do check out, and Grafana Labs, more than 50% of the engineers actually contribute towards the open telemetry. And there is an agent called Alloy from Grafana, which is written on top of open telemetry, but it's more compatible to LGTM. But yeah, open telemetry is a popular, widely used standard tool, you can say, for given any language or any application or any technical products, right? So there are three pillars: traces, metrics, logs. Then there are open standard for open telemetry that we need to follow, and the LGTM stack where we see the Loki captures the logs, Grafana for visualization, dashboarding, right? Tempo for traces, and Mimir for metrics. We will see that in demonstration, right? Now, the trace waterfall. Now, this is very important. The let's say just considering the one of the service checkout, right? But if you see there is catalog lookup. There is a query to the Postgres. There is payment charge retries if but it fails, right? So Kafka published to the queue, there is queue wait, and ultimately, following all these steps, you get a response. It might take so much time. For example, here, I showed that it might take 4.8 seconds. That's too much, right? For checkout. Okay, so we'll see that in our dashboards, like that would be dynamic again. Let's say if we see a checkout or product service, while I demonstrate, right? Now, uh, uh, coming to the why I came up with this project, or the demonstration is the observability, as you all know, is very important, but how to observe our systems, right? That's also very, very important to understand the observability tools, to understand you know which tool works perfectly, for an application use case, right? So, the outages, just to prove, right, the outages live in the chain, not the box, right? Most of the production incidents are, the dashboards are green. It's in not tough to identify, what's going on with the services, right? So they're like chains of, e-commerce is a good example, right? So there are chains of requests, and in between those services, what happens? Okay, there might be failure for in one of the service, and it goes back to the original one, right? So traces are metrics. Yeah, they do give stats, they do give the aggregation, the counters, but your traces are the only records of that chain, right? That you will see when we span the trace, and we span each of the service dependent services. You will be able to see the traces, right? So they no they an outage is maybe wrong place to learn observability, but we in this I run some kiosk testing in this project to understand where are the failures, and that reflects on the dashboard, the traces that can be viewed, right? I'll just keep a check on the time. All right. Okay. Now, this is just a simple architecture diagram. This diagram depicts about how the request goes and what all layers we have here. Right from the front end, then API gateway, checkout. The catalog, the inventory. Of course, we have the product inventory from where in the database, it gets the product whenever a product is selected. So here, I'm not talking about only one user, uh, viewing a single product. It's about e-commerce website is about like thousands, lakhs of people clicking on the same product, maybe, right? And on the right hand side, you have the telemetry plane, which I was talking about, right? The open telemetry collector collects the metrics, traces, and logs from this application. Where here we have two languages, Java and Python, and you can see we have Kafka. I use Red Panda for lightweight because all is running in local. Then the Redis and the Postgres, right? Redis is for cache mechanism for fast loading. Postgres, of course, to store the inventory or any other use cases, right? Now, moving on to the next thing, as I was saying, right? So you see everything is green, but you never find out what happened with the service, or until unless you go and check the trace, right? So that we'll also see in the demonstration. All right, so this is a simple, again, a diagram to understand what happens with the open telemetry, how the open telemetry collector collects the the matrices from the services, and it pushes to the Tempo, Loki, Prometheus to collect all the data, and the dashboards. So I have over 11 dashboards to show today, right? I'll also show Open Telemetry Collector. Here I've used Grafana Cloud so that it would be easy, not much load on my local host. Uh, the, uh, in Grafana Cloud, we will see how this dashboard behaves during load and then during the chaos, right? So we'll also see like cross signaling. We'll also see if time permits, right? We'll just see how the trace between the Python and Java as looks, in that services, right? So, all right, yeah, just to give the the technical stack of what I've used and what I've done, right? So hope you all got just about what's gonna be the session today about, right? Of course, we'll see on Grafana Cloud how when the chaos is applied, and we find out the services in the traces are throwing errors, and they're not responding, maybe due to network latency or any other reason. Right, so the demo would be totally dynamic. So let's see how it goes. But yeah, ultimately I can show the dashboards, how the traces works, right? How the metrics, logs, and traces are applied. I try my best to show on the dashboards, to give the insights of a service end to end, right? Uh, any questions here till now? This was just all theory. No, all right, cool. So now I've been just trying to see that whenever I give a demo, what maybe I might uh, forget some steps, or I might not the intention of whatever I thought of showing to the audience. I might forget about it, some of these steps, and then not show the right thing, right? So I came up with my own demo assistant. So meet the demo assistant here. Okay, which will actually run through the demo. It can listen, it can talk as well. So this is the first time ever I'm trying to demonstrate using demo assistant called Jugni. I've named it as Jugni. So let's try to load the project here and see how it runs step by step. And of course, I have a backup plan for it. If it fails, I have full control, manual control over how to actually run the demo, rest of the demo, right? So let's see. Yeah. So hey Jugni, hey Jugni, how are you doing today? Can you introduce yourself to the session attendees today? Can you load a demo for me? Cool. So the agent has loaded the demo. Let's see the steps it will run through for me, for the demo. Oh, wow. So it has identified the steps. These are, see, most probably these are the steps. Oh, sorry. So most probably these are the steps. It's gone. Let me load it. Right. So these steps are, where, I think about, running a demo, step by step, what needs to be loaded, what's need to be shown, all those steps I have captured. The let's see how agent runs through these steps. Okay. Hey Jugni. Hey Jugni, can you run the demo? All right. So I have put a check that it should not load the demo by mistake, right? So there's a check here with a manual intervention. So I'll manually run the demo. So I'm bringing up the stack here, all the containers. I use Docker Compose to, bring up all the, containers. Let's see, there's a terminal which shows my containers are healthy or not, or maybe some errors, but I have a recovery agent here which actually diagnoses dynamically if there is a problem, right? So if there's something not loading, it does some diagnosis and try to load it. Now let's see. All right, that's fine. So, um, okay, so let's ask Jugni to explain this step and move forward. No, move to the next step. Hey, Jugni, can you explain the step 2 for us and then move to the next step? Hey, Jugni, maybe it's still going. Let's do it manually. That's fine. So here, in the first step, all the containers are healthy. Let me open the Docker and just show you. We have shipping service, inventory, catalog, payment, notification, risk engine, checkout. We have Redis running, Postgres, Red Panda, API gateway, Toxic proxies to introduce some chaos here. Right here you see right, Odin collector. And we also have a front end somewhere, which actually right front end. Okay, so these are the containers already running. So let's go to the next step, right? It now what does this step do is it checks my all the services are up and running or not, right? It in the backend it hits the services and try to see whether all the services are up or not, right? Let's ask Jugni to explain it. Hey Jugni, can you explain step 3 for us? Move to the next step, right? Here, I'm trying to show the how open telemetry actually pushes the metrics to, right? So if I just scroll up a bit, sorry for the clumsy terminal here, but now if you see this right, how the hotel collector config looks like, right? So here's the endpoint, then the collector, Prometheus read write. Here you got Loki. Everything is environment variable, setup. So this is my Grafana Cloud Loki URL, Grafana Cloud Tempo endpoint, and the Grafana Cloud Prometheus URL. Right. So let's ask Jugni to also explain this for our audience. Hey, Jugni. Hey, Jugni. Can you explain this step in detail for our audience? All right, maybe couldn't recognize what I said. Let me ask again. Hey, Jugni, can you explain the step 4 in detail? Move to the next step. So here we are introducing load. You can see this chaos playbook, right? So we are introducing load plus chaos, which will actually inject faults. Let's see if we do have. All right, right. So here are the 7 incidents which I configured. You can see the cache stampede, n+1 queries for the PostgreSQL, raw lock, for the inventory, payment retry storm. It will continuously, have multiple requests on the payment gateway, right? And of the consumer lag on the Kafka, see whether messages are really processed or not. And service slowdown, right? You can actually delay a service to understand after how much seconds it's failing. And risk engine slowdown, Java, JVM plus the Kafka. So to inject all this, I've created a script, and that's already running in the background, you can say. uh, so let's ask Jugni to explain again in detail, for the audience, and then move to the next step, right? Hey, Jugni, can you explain step 5 in detail for us? Move to the next step. So here, what I've done is, now this step actually restocks the inventory. So you can see there's an approve button here, right? So even though, if I ask Jugni to approve it, it can't, right? Jugni thinks that it has approved it, but it can't. So I'll manually approve it, so that we run a restock script, which will actually restock the inventory, larger inventory, let's say 50,000 or so, for us to actually see the real traffic, right? So it will wait for some time, for the it also has a check where it the metrics are actually flowing to the cloud, no, the Grafana cloud or not, right? It ensures the validation step is there to ensure that the inventory is present, right? So let's wait for 30 seconds. Also, after that, I'll ask Jugni to explain, right? So, oh, that's great. So if you see here, right, 6:45 checkout request in last 30 seconds. That's great. Right, let's ask Jugni to explain this and move forward. Hey, Jugni, can you explain step 6 for us? All right, thanks. That was great. Right, so as you have seen, the okay, yeah, let's move on. Next, let's see it logs into the browser and auto signs in. If not, I'll log in manually. All right, I think that doesn't work. That's fine. So let me log in. So Jugni is quite helpful. It's keeping up the pace of the demo with me. Oops, I think it's something in the background, but that's fine. So there's my, Grafana Cloud account. And let me quickly log in. Right, so I'll launch my Grafana Cloud landing page where we have all the dash configured. Custom the mesh. Right, let's infrastructure. Cool. So this is a basic dashboard, which I wanted to show that here, all looks good. There are 10 containers which are running healthy. You see the CPU, it looks good within the threshold. You see memory 60%, that's okay. Right, and here you see the ingested rate per the span which we have seen, right? Open telemetry span configuration. Here I'm trying to capture that spans. Checkout has 30, 39, and all looks good, right? So everything is green, right? But when we introduce the chaos, let's see how it behaves. Let's also see some other dashboards here just to understand, right? Let's go to chaos console, right? Nothing is running. That's fine. That's good. I haven't triggered any chaos here. So there's no failed checkouts or something like that. That's fine. Let's go to PostgreSQL, right? So this might be some no last. Okay, let me just 15 minutes and see, right? No worries, that's fine. So, but yeah, here fail inventory reservations or no data, or raw log weight also looks fine on an average, right? There's no latency, uh, looks good, right? So this is just to show that the dashboards looks good, right? Especially the misleading one, right? Here we see, oh, if services are failing, what we're gonna do here? Let's go to the dashboard. Is my resources less? Is CPU is fully utilized, or memory is not sufficient, or what's happening? So we tend to design a dashboard which actually shows the infrastructure, but not the application services as such, right? So most of them are dependent. So open telemetry plus the LGTM stack gives us a lot of insights. So I've designed these dashboards to understand how it behaves when we apply the kiosk. All right. And yeah, let's say the service rate, right? Okay, request rate. Of course, we don't have much requests. The error rates, nothing, because uh, we generally configure on the service mesh layer, where we try to find out the 4x and 5x errors, but that doesn't actually give a complete insight of the service, the entire service. As I apply the kiosk, there will be something delaying the service. There will be cache issues in the Redis. There might be some message queues piling up, right? So let's also see that. Let's Okay, got it. So it has been waiting for me to the next input. I'll go by manually so that it opens more for me. So I've shown the service red dashboard, right? Let me just skip these steps. Hey Jugni, move to next step. Right. So it again now try to launch the Ghost infra URL, which already shown, right? But it seems that it has missed the step. That's fine. It happens. It's an AI agent, right? So uh, let us move to next step. So these are all the steps, the browser steps, which I've already shown, the the service map. The let's also see the distributed tracing here. Hey Jugni, move to next step. Right. So let's go to the distributed tracing. All right, cool. Right. So you can also already see, right? I mean, this being running in local, maybe, here the duration 2 seconds for one, a service, right? So it's too much of time, right? So you can see this slow checkout traces, but it will increase, when I apply the kiosk. So let's move to the next, right? So yeah, okay. This step is injecting the failures, which I was talking about, right? The chaos steps, like the incidents, right? Let's see. This is a critical one again. Uh, Jugni will not run this. Let me approve manually and see, right, what it's doing. So it actually, right, is running this 7 chaos scripts. Reload services consumed. All right, let's go to Docker and see whether it's actually recreating it or not. Okay, let's wait for some time. So we have traffic. Now we are trying to inject the failures and see, how our dashboard looks, right? And, again, just configuring, the infrastructure metrics, or, it's not all about infrastructure. I've seen that many teams, many of them have actually not implemented traces. They have just implemented metrics and logs, and they just dive into the logs and cannot identify which service has failed, right? Logs are good place to look at, but it eats up a lot of your time, looking at a each log line and understanding which service might have been failed, and going to next, and then which service we might not have that knowledge as well, right? Because in a team, if I talk about application team, each of the member has got their own role or own service to look after, and they might not be able to understand other services, right? In fact, in the support team, the SREs or maybe the uh, cloud team, right? They might not have the insights of the application. Okay, so that's where this comes handy. Let's see if it will actually run something for me. No data yet. That's fine. So let me actually, run the chaos. Let it run in the background. So I always have a backup here. Any questions here till the time we see our chaos loading?
Satpal, there are few in chat. So
All right. Yeah, where is the chat? Oh, you guys are not able to hear Jugni?
No.
No? All right, that's fine. But you were able to read the transcript, right?
Yeah, that's visible.
yes.
All right. I did test it on Google Meet. It was working fine. I'm not sure about Zoom, but it worked fine. All right, why I'm not able to see the chat here? Okay,
Another
it's shown
window.
everyone, right? Yeah, my bad. Okay, it's all about Jigni. Okay, how it runs, collects data here as a separate Docker container in local. How it runs and collects data here. Okay, so hotel hotel receivers are there, right, in the pipeline, right, Keshav? So hotel config has, we need to configure receivers, right? So hotel has, two things here. It can pull and push. Both mechanisms work with hotel. Either your application should push it to hotel, with the hotel gRPC endpoint, or you say hotel to configure a receiver in the config file. So what it does, it continuously polls that endpoint of your application where it goes for like slash metrics, or the you need to also configure your custom logs if there are any, right? Or by default it goes for the container logs on Kubernetes, right? So there's a specific path for container logs, or pod logs, right? So it already identifies by default and pulls the logs, right? For traces, you need to actually configure environment variables and try to give the gRPC endpoint, or the OTLP endpoint, right? So that the application pushes the traces to the hotel collector, and hotel collector has already configured backend tools, right? Like Loki, Mimir, and Tempo. It pushes the respective signals, right? Okay, how do AI-assisted observability agents based on empowers non-textual data like metrics and traces and provide insights on the performance as opposed to logs, which are textual data? They would be able to, or any specific models. Rajesh, I would like to answer that later, or maybe we can ask Jugni to answer it. Okay, let's see. Yeah, Jugni can actually answer our Q&As as well, or maybe I have an agent there. Let's see. Yeah. So is a observability agent connected to different system through MCP? Uh, AI assisted observability is again a gray area as of today. When we talk about I mean LangChain, LangGraph, right? Those are powerful tools again. MCPs are something which are good. I'm not saying that MCPs are not worth using, but MCPs, we have seen some lags, as compared to API calls. Okay, but we need to understand the purpose of an agent. It's not about uh, just designing an agent or maybe using MCP for all agents, right? So there should be proper modeling of agents. So in today's scenarios, we need to use multi-agents orchestrated by agent. There should be an orchestration layer. Then there are multiple agents which actually does their respective jobs, right? So you know, uh, actually, Jugni have modeled on the same concept. It uses MCP, it uses direct API calls. I have a graph as well to show, but yeah, let's for now, right? There are so many ways to uh, create agents, but you need to understand the requirement of an agent, right? It's not always MCP that works. It's not always an API that works, right? So there are different models which serves their purposes, right? So you can't use Opus 4.7 model for all the purposes, right? It will eat up your tokens unnecessary, right? So you can degrade the model for certain purposes. You will actually see in the Jugni, agent, I have created a graph as well. So it's, you'll understand better there. Yeah. Let's see whether chaos is okay. Fine. Let it run. Meanwhile, I'll just show, all right, the graph here, right? So I have created these agents, the web UI which you see on back of it, we have so many agents here. I talked about orchestrator, right? So it uses Opus 4.7, which actually has the API calls on which step also, I have, try to uh, add it as a, metrics or something like that. Yeah. So that I can actually understand, how the agents are behaving, or which step and how many tokens actually they are burning, right? So planner, again, Opus 4.7, because it's a complex task, right? Again, I was talking about the scenarios, right? It also applies to the AI observability, right? Narrator, you can see the API calls, input tokens, output tokens, right? Total tokens. So this talk is not about this, but by the time chaos runs, I'm just trying to show in AI observability as well. We need to use such models, but again, it's a gray area. It's we have so much to actually work on the AI observability. But I'll show you how Grafana has actually enabled us AI agent on the cloud itself. We also have now AI agents in open source Grafana containers. There's quite good document for open source, but by default in Grafana Cloud, the AI assistant is available. That's what we'll see, right? Let me quickly check. Is there any? All right, let it run some 7 steps. But yeah, here I've used drag to actually index my project. The demo project goes in the mesh project so that the retrieval is faster, right? It uses OpenAI key. Here it's a user. We have Q&A. I was talking about Q&A. So let's actually, see whether Q&A is working or not. Let me pull up the question from the chat. Where's the chat, right? Okay. Let me just minimize a bit. Right. All right. How do we, okay, let me start recording and see. All right. Maybe it's not working. Fine. That's fine. Let's ask Jugni here. Hey, Jugni. Okay. So a user has a question. How do AI assisted observability agents based on LLMs parse non-textual data like metrics and traces and provide insights on performance? Okay, maybe it timed out. Let me just quickly, because it's running on localhost, I have, kept certain, checks there. Hey, Jugni, a user has a question. Can you answer it? How do AI assisted observability agents, maybe it's not listening, I doubt it. Hey, Jugni, how do AI assisted observability agents based on LLMs parse non-textual data like metrics and traces? Yeah, move to the next step. So you have seen, right, how I designed this agent, Rajesh. No, it couldn't answer because it's not designed for that purpose, right? So we need to understand when we design an AI agent, right? So you need to actually keep in mind that exactly the guardrails are working. Absolutely, right? So again, this complete Jugni is not for this session, but I just wanted to demonstrate something using AI agent so that how AI agents are also helping us in solving our problems, right? So let's move to next. Of course, we need to transact upon these things and progress and refine them as we go. But this is my first attempt, on Jugni, right? So let's see, where is our kiosk? Okay. Right. So restart traffic. That's fine. We are slightly overrunning. I think it's 9, but yeah, let's just do this. Or no, I can show the previous data right now. I've already quite some time today. Let's go for it. Yeah. All right. Yeah, it's actually running. Sorry. Right. So here you see the failed checkouts, right? But when you go here on the dashboard, right? It's all green, yeah. The CPU is okay, the memory is okay, the metrics all looks good. It's the ingestion, right? But the kiosk console says, right, there's failing, some fraud queue lags, failed checkouts, right? Now let's go to incident war room and see how many incidents are actually. Oh, right, 4 incidents are already up. Okay, yeah, this just shows the scenarios of each of the incidents, right? But the most important part here is the traces, right? The traces. Oh, wow, 13.3 seconds, you see? But there is nothing red on the dashboard apart from what I've configured, right? The checkouts and all. But, if you see the general dashboards, there's nothing showing up, right? I mean, how would a user actually transact upon those dashboards? How where to navigate? As I said, right, logs are quite difficult to dive in. Okay, so let's see here, how does this trace look like? Right, so this is the span, the waterfall, right? All right, you see, we did some chaos on checkout service, and this is where it's showing us red, which means this is something in error. But you know without these traces, imagine how difficult it would be to actually find out which service has failed, right? So this is like, we have deliberately done the chaos, and I know, where it's failing and what. But imagine in a real time scenario, how would you actually find out which service is failing? So traces is the place where you can actually see, right, from the API gateway, the checkout catalog, then checkout. But somewhere in the checkout going forward, it failed because it took more time, right? So this is a lag, but the user experience says that it's lagging, the checkout is not happening, there's something wrong, right? But the SREs don't know until unless they come and see the trace, where exactly it's failing. They would assume that, okay, fine, it's lagging because maybe it's out of memory. The containers are out of memory. Maybe the CPU is high. That's the first perception everyone has about a dashboard. Okay, where is my now? How does my cluster health looks like, right? If it is green, they'll just say, okay, no, let's wait for some time, and then you're losing time, right? So your mean time recovery should be less. So this is the way, what you transact over from the dashboards, right? And then you configure your traces from Open Telemetry Collector, the metrics traces logs, and from there, you come to the traces to understand where the problem exists, right? So there are many scenarios. I mean, I just wanted to trigger a few of them and try to just show you guys how it works. Not the cluster health is green. That doesn't mean everything is working fine. You need to have the traces enabled to understand the service hop and where exactly the service is failing. Not the origin, maybe not the next step, but maybe it failed in the Postgres due to connection lost, or maybe due to stale connections, right? It can happen, right? So deliberately doing the chaos, you now understand. This is just one example, but there are so many of it. Just keeping a tap on the in our time, right? So here, as I said, right now, AI assistant, right? So this is available right away from in the Grafana cloud, but you can also have enabled in your Grafana OSS. There's a step-by-step procedure that's already documented in the official Grafana documentation. You can enable a Grafana agent provided you need to have LLM key, right? So let's ask, so what is wrong in the traces, right? So it just scans the dashboard here. Try to find out the error, right? Any questions here? Or in the chat, someone has.
I have one, Satpal. Like,
Yeah, go on.
in this scenario, what is the type of chaos that has been injected into the checkout service?
It is the service delay. Let me go to, because it's taking, see, it's taking the, okay. So all the 7 scenarios has been triggered at once for this demo, right?
Mm-hmm.
Now, so payment retry storm might also be one cause, right? So it's giving me the entire summary here. Okay. So the payment retry storm here is the primary reason, that the checkout read timeout fires, right, before the payment service responds, right? So I have also scripts for rotational scenarios. Okay, just to keep the demo within time, right? I fired all of it, all the 7 incidents, right? It might be any case. Okay, so the inventory lock contention might also be one of the case, right? Then the shipping service unreachable. Okay, so with this AI assistant, because see, all the systems are connected, right? So I've applied chaos on all of it. So on which step failed, here my AI assistant is actually finding out based on these traces.
Understood. Yep.
Hope that helps. I mean, if
Yep.
it would have one scenario, I have a rotational script as well where only one scenario is applied at a time, right? That actually might give more insights, but I just try to show more data on the dashboards to make you guys understand that what happens when we apply these kind of scenarios on Kafka, Redis, and all this technical. So you can try it out. I'll share this project on GitHub. I'll share that link, and then you guys can try to provide it, right? I mean, you need to also have that much resource in your laptop to run, and if you have the Grafana cloud account, right, that would be great. Or else you can also try it in your local. That's absolutely fine, provided you need to have that amount of resources in your laptop or your desktop, right?
Mhm. Yep. Thanks, Satpal. That
Okay.
helps. Yep.
Yeah. So this is what, like, end to end, most of the teams miss out on enabling the traces, just because they don't understand how to do it. Because I get a lot of queries. Why aren't the logs sufficient to debug, right? So we are in a world today, all right, where we look up to the AI agents, speed up the processes, speed up the operational overheads, looking for answers quickly, right? Minimize the production downtime. Okay, so this helps a lot, and AI assistant RCA, you can see, right? It's enabled on Grafana Cloud. If you're using enterprise, that will already be there with your organization. If you want to use any of the Grafana plugins as well, right? You need to have a open API where you can enable the LLM plugin and use for querying or try to answer the root causes, right? So there's so much to do it. In one of the demo, I also after querying and understanding that okay, there is an issue. A Slack channel was opened and an incident was actually opened in that channel so that the SREs can jump on and look at that channel. So everything was automated. So there's so much to it. We can do a lot more provided it's our use case or not, right? So soon maybe you'll see some SRE agents which actually does remediates the issues, right? This AI assistant also does it. Just we don't have much time. We're already about 10 minutes over for our time. So maybe I can cover that in later sessions whenever it's possible, right? Any questions here? Okay, then I'll